Differentiation of natural logarithmic functions. Logarithms to the base e are called natural logarithms. The notation lnx is used as an abbreviation of log base e x. The function y equals lnx is the inverse function of y equals e to the power of x. Exponents and logs are inverse functions of each other. Note, log base e x, or lnx, is defined only for x values greater than 0. Natural logarithms obey the same laws as logarithms to any other base. So these are some of our laws of logs that are in our formula book. So ln ab is equal to ln a plus ln b. So multiply becomes add. Ln, so natural log a over b, is equal to natural log a minus natural log b. So divide becomes minus. And ln a to the power of n is equal to n ln a. So the power comes down in front. Using the laws of logs before differentiating can simplify the work. The following is worth remembering when evaluating the derivatives of natural logarithmic functions. Ln, so natural log e to the power of k equals k for any k value element of the real number set. For example, ln1 is equal to ln e to the power of 0, which is equal to 0. So ln, or natural log. Ln e is equal to ln e to the power of 1, which is equal to 1. Ln e squared is equal to 2. Ln root e is equal to ln e to the power of a half, which is equal to a half. The rules for differentiating also apply to natural logarithmic functions. Suppose u is a function of x. If y equals ln u, so the natural log of u, then dy dx, the derivative, is 1 over u multiplied by du dx, the derivative of u. Find dy dx, the derivative, if y equals ln x squared plus 1. So if y equals the natural log of x squared plus 1, then the derivative, so we follow this formula, so y equals ln u, so the u in this case is x squared plus 1. So then dy dx, the derivative, using the chain rule, is 1 over u, so 1 over x squared plus 1, multiplied by du dx, the derivative of u, so the derivative of x squared plus 1, which is 2x. So then we multiply top by top, bottom by bottom. So 2x is really 2x over 1. So we want to do it 1 times 2x is 2x, x squared plus 1 times 1 is x squared plus 1. 2. Y is equal to natural log sine x. So again, we use our chain rule. So if y is equal to natural log of u, then dy dx, the derivative, is 1 over u, so 1 over sine x, multiplied by du dx. So the derivative of u, the derivative of sine x, is cos x. Again, cos x is really cos x over 1. So we do top by top, bottom by bottom. 1 by cos x is cos x, sine x by 1 is sine x. 3. Y is equal to the natural log of root x squared minus 3. So first we rewrite it as natural log x squared minus 3 to the power of a half. Then what we can do is simplify this using our logs laws. So one of our logs laws is log base ba is equal to a log of b. So the a, the power, goes in front of the log. So the half, the power, goes in front of the log. So we have half natural log x squared minus 3. Next, we use our chain rule. So dy dx, the derivative of y with respect to x, so we just bring down the half. Then we differentiate. So we have dy dx equals 1 over u, where u is x squared minus 3. So we have 1 over 3 multiplied by du dx, the derivative of u, so the derivative of x squared minus 3 is 2x. So then we just multiply. So 2x is really 2x over 1. So we do top by top by top. So 1 by 1 by 2x is 2x. And then bottom by bottom by bottom. So 2 times x squared minus 3 times 1 is 2 times x squared minus 3. And then we simplify. So we can cancel out the 2 on the top and the 2 on the bottom. And we're left with x over x squared minus 3. Part 4. Y is equal to x natural log x. So x and ln x are stuck together, which means multiplies. So we're going to use the product rule, which is dy dx, the derivative, is equal to u dv dx plus v du dx, where u is x and v is natural log x or ln x. So dy dx is going to be u, which is x with brackets around it, multiplied by dv dx. So the derivative of ln x or natural log x is going to be 1 over x. So we got that from our formula book, or we just know it. 1 over x plus v, which is natural log x or ln x, times du dx. So the derivative of u, the derivative of x, is just going to be 1. Then we simplify. So x is really x over 1. So we do top by top, bottom by bottom. So x times 1 is x, and 1 by x is x. And then natural log x times 1 is just natural log x. And then x over x is 1, and we just bring down the natural log x. So we get 1 plus ln x.